Welcome back to Agentic AI, the future of intelligent systems. In our last episode, we explored how the role of the software engineer is evolving in the age of autonomous agents, from coding systems that follow instructions to designing systems that think, adapt, and collaborate. But this evolution doesn't just reshape roles, it reshapes how work gets done. In today's episode, we step deeper into this shift by focusing on the next emerging practice: agentic programming models, the new interface between human intent and machine execution. Traditional software engineering was deterministic. You wrote logic, compiled it, and watched it run line by line, function by function. In agentic systems, the interface becomes conversational. Intent is captured in prompts, structured tasks, or high level workflows, and then interpreted by autonomous components that reason and respond dynamically. It's no longer about defining every step, it's about shaping the boundaries of thought and action. This new model requires a mindset shift. Instead of controlling flow through rigid sequences, engineers must now orchestrate conditions, define policies, and guide behavior through structured affordances. Think less about what a system must do and more about what it should be allowed to do in context. Agentic programming becomes a game of constraints and choices, not commands and compilers. At the heart of this transition is the prompt, not just as a string of text, but as a functional primitive. Prompts define context, instruct roles, and determine how an agent approaches a problem. In agentic systems, prompts are becoming as important as functions once were. They encapsulate logic, express intent, and drive computation dynamically. But prompt engineering alone isn't enough. What emerges next is a composition layer, an abstraction that combines memory, model routing, tool invocation, and multi agent coordination. It's here that new programming patterns are born. You might start with reflective loops, where agents pause to assess their progress, or delegation chains, where agents pass tasks to more specialized peers, or policy bound workflows, where execution is shaped by organizational constraints, from cost ceilings to compliance mandates. In this new architecture, memory becomes first class infrastructure. Instead of databases storing static facts, memory layers hold evolving context, user preferences, past decisions, environmental feedback. Developers no longer write logic in isolation, they write it with awareness of a system's state of mind. As a result, debugging transforms too. The question is no longer what went wrong in the code, but what did the agent believe to be true when it made that decision? Logs now include reasoning traces, memory snapshots, and model choices. And observability isn't just about latency, it's about cognitive transparency. All of this requires a new breed of tooling. We're beginning to see IDEs designed for agent orchestration, testing suites that validate behavior under changing context, and simulation environments where agents can be stress tested in hypothetical scenarios. Infrastructure too is adapting, with support for dynamic model scaling, energy aware routing, and memory optimization baked into runtime layers. And through it all, collaboration is key. Agentic programming isn't a solo endeavor, it draws from disciplines like UX design, ethics, security, and policy. Software engineers now work alongside prompt architects, governance leads, and cognitive designers, each shaping how agents act in the world. In the end, this shift isn't just technical, it's cultural. We're moving from coding systems that do what we say to crafting systems that figure out what we mean, from precise logic to purposeful guidance, from control to collaboration. Thank you for tuning in to this episode. As the nature of software continues to evolve, so too must our methods, mindsets, and models. Stay with us as we continue exploring the living architecture of intelligent systems, one prompt, one agent, one behavior at a time.